never had one lesson.
Hi, bit of a different teardown today. We've got this new model Casio CT-X700 keyboard. It's $179 US, and somebody asked me to take a look at this and how they're actually doing this for the price, because apparently for this sort of price, it is an absolute killer because it has full velocity, a full 61 key velocity piano keyboard on it. Now, I've actually done a Yamaha PSR-80, I think it was, quite a few years back, and I'll link the one in down below and at the end as well. And that was a keyboard with velocity control keys, well, sort of, from the 1980s. And it was really interesting how they implemented that. So I thought this might make an interesting teardown. So let's have a look at it. And no, I can't play to save my life. I am not the least bit musical, but I am interested. Obviously not in the processing and stuff like that. That's okay. Casio has some whiz-bang technology that goes into this that makes it, you know, sound like 600 different instruments and all sorts of stuff. And which is really, you know, amazing. I'm sure they're doing a good job at that, but I'm really more interested in how they do the velocity keys, because if you look at the PSR-80, that Yamaha from the 1980s, I think it was limited to like groups of keys, and it was only like 3-level velocity or something like that, whereas this one seems to be across as many keys as you can press at once, and all individual based. And also, it seems to be like not just a fixed level, it seems to be like a pure velocity level. I'll just demonstrate that here, and yes, I am feeding this signal directly into my camera, so that's how it's so good. And here we go. Like, okay, I'll just... And the harder I hit that, the more it sounds like a piano. It's they're like truly velocity, or at least, you know, I'm not sure how close it is to an actual, you know, an actual piano, because I'm no jack all about this stuff. But anyway, apparently that's really quite impressive for the price, $179 US. So I won't pretend to know all the functionality on this thing, but it's got like up to it's got 600 tones, 195 rhythms, 160 song bank, and all sorts of stuff. And yeah, it's very impressive, I'm sure. Once again, especially for the price. And it's got 2 large speakers on here. I don't know if they're just single cone, like full range ones, but they are quite large, as you'd expect. And on the back here, we've got a pedal interface and audio in. Not sure why. I don't know. Once again, I don't know anything about this music stuff. DC jack and headphones / line level output that I was able to feed into my camera. Apart from that, just a USB on here, and it's got MIDI interface and whatnot, however that works. Nah. And it's powered from 6 AA batteries, which is very impressive. The original Yamaha from the 80s had like C batteries, wasn't it? Real pain in the ass. Anyway, 9.5 volt 1 amp jack or 6 AA batteries. Might have to measure the power consumption of that. As for the rest of it, well, these moldings down here might give us a clue as to how it's sort of the velocity keys work, because all this stuff along here obviously has something or a lot to do with the velocity keys. Oh, I think I can see the board. Yeah, I can see the PCB, so it's not completely sealed on the bottom there. Anyway, let's tear it apart. I find it interesting that these come in blocks like that. There's 3 of them along there, so I'm going to open that up first and see what's what under there. Aha, right away we see the same technique used in the Yamaha keyboard from the 80s, and that, like, they've got this felt in there that the backs of the keys just, you know, it gives them just a nicer feel when they come back, or maybe, you know, no sound, sort of deadens the sound or the response when you push the key in like that, and then it, you know, comes back. Just gives it a little bit of give. So there's absolutely nothing different about those 3 sections there. So why they've got those 3 individual plastic things, well, there could be several reasons. One, they didn't want to make one single molding that thin, that long, perhaps. But why do they have this at all? Why doesn't this just come over as one big molding? Well, that's got to have something to do with the assembly of this thing. It's got to be assembled in a certain way, and maybe they like put the felt in here as a step, so they need access down there to put the felt perhaps, and it's just got to be some sort of aid to assembly, I would think. All right, this could get a bit tricky. It's a separate section, so the keyboard section seems to be separate from the rest of it. Oh, and the center console. Hey, there we go. Oh, we're in like Flynn. We're in like Flynn, look at that. Single-sided, still got the single-sided board for the cost reduction. Nice, and they're just all, let's have a look. Oh, this is fantastic. If it wasn't for this modern PCB here, this would be straight out of the 1980s. As I said, single-sided PCB for cost reduction here. It is still, as cheap as PCBs are these days, it is still cheaper to actually manufacture a single-sided board. That's why you'll still find them in high-volume consumer products. You know, TVs, things like this, microwave ovens, washing machines, and, you know, all sorts of like white goods and all sorts of, stuff like that. So it's all, I love it. We've just got our 8-pin dips here on a single-sided board, a bunch of electrodes, and the connectors, the LCD panels mounted directly on the back of that. Look at that, absolutely fantastic. Do they have a ribbon cable for that? I don't know, we might have to flip it out, but wow. And look, old school wiring straight onto links. Look at that. Someone at the Casio Oompa Loompa factory is, hand sold, are they? Yeah, no, they've put 2 links in there and then soldered the wire between the individual links. Look at that. Wow, nice. And old school ribbon cable just going off down to the keyboard down here. This is terrific. And check this out. All the magic happens in one big Casio custom ASIC. Unbelievable. I'm doubting that this is an FPGA. I have to look at the smaller chips, whether or not there's like an external E2 PROM or something like that, but everything's in there. We'll have to take it out and look at the the other side as well, because where's all the memory and everything else? But Casio have the clout to, do their own custom ASICs for something like this. I don't know if this is a new one specifically for this keyboard, because I haven't torn down any other Casio keyboards. But yeah, it's like there's nothing in it. But this is how they get the cost down. This is $175 retail or whatever. That's the street price, US retail keyboard. And for something of this size and complexity, it's just, they've got to save every cent they can. And it's obviously cheaper to have someone hand solder these ribbons on there like that. I'm sure it's very quick and easy. They might even have maybe a bit of a jig for it or something like that, than it is to, piss money away on a connector. Oh, don't want that. And you'll notice the attention to detail. Look, foam. They put a foam strip all the way along that. The only reason you do that is if you want to have an acoustically sealed chamber all the way down in here for your speakers. I mean, it's not the world's best speaker design, but you don't want it leaking out, and it might sound a bit messy, or insert audiophile wank word here. So but there are real. There's real science that goes into the acoustics of boxes and stuff like that. But obviously that's what they're doing. Maybe that's what they're doing here with the foam as well. But why they did on these and not on these, I don't know. Anyway, it's interesting. But the foam is mainly just at the back there. So maybe that was like a big port. I don't see any up the top or anything like that. You can see that the keys are manufactured in 2, 4, 6, 7, plus the whatever you call those keys up there. Told you I know nothing about these. And they've done those in one molding, so they just duplicate that across the multiple keys like that. So we can whip that out and should start to get in like Flynn. Anyway, down on the input stuff here, some LM4565 low noise op amps down in there. A couple of little common mode chokes. Got some Scholastic down in there. Somebody had a little bit of fun. I thought they had gilded the lily up here with a double-sided PCB, but no, that one's only single-sided. That's just for the volume pot on the front, but that's nice. I guess they needed the setback on that, so they couldn't do it on the main PCB. And for the power amplifier down in there, they've got a TA8227, and you can tell it's a power amplifier because the middle pins, like that, join together. Nice big fat pins. Oh yeah. they'd actually be power pins, and also, of course, extracting that, because we're not talking about super power here, but they'd be extracting the heat out of the die as well. That's their job. That's why they're thick. Aha, there's your memory on the back, as expected. We've got our working memory and our flash memory, of course. Was there a header on the top? I don't know. There's lots of, production test points down in there. Maybe they program it through here. What's this over here? I don't know. It looks like they got a cap on each one of the input pins here from the various, going, is that like EMC? Something like that. And there's our driver down in there. No surprises just for finding one big full-range driver, no separate tweeter on that thing. There's no need. So wires soldered directly on, as we're seeing on the other boards. None of this crimp connector rubbish. That just cost extra production time, extra cent or whatever. So they're shaving the cost there. Obviously, they've got this wall up here that's part of the acoustics. They're kind of trying to create like maybe a chamber in here and have it sort of come out the side. I'm sure they've done their testing. It's not, it's not going to set the world alight for 175 bucks, and that's just a regular paper cone. Nothing special, but it does the job for an internal keyboard speaker, and I'm sure they've done at least a little bit of acoustics here to make it at least not sound completely crap. Part number for those playing along at home. Well, I really am starting to like the sectionalized construction of this thing with the molding there. That's, the speaker just wraps around like there. The keys obviously like screw on top like this. We'll be able to take those out, no worries. And all the center console like that, you can work on that separately. You can test that separately, bring these together, assemble them in different parts of the production line, then, bring them together. There'd be a person or two doing like final assembly on each one. Well, it's probably more than a person or two. I don't know the volumes on this. It's got to be large. Anyway, it's very nice. All right, will this be the big reveal? That's, nope. Because there's some, this has got a, hello, individual, okay. No, okay, no, look at that. It's not, I thought that was one molding. It's not. Comes apart as two separate moldings. Looks like the keys have to come out like that and then flip up. Aha! Now we're in like Flynn. Okay, so I don't see any like multi-level stuff. This is obviously the part that's pushing down here, because this we actually saw on the bottom side. That's just like a stop. That's just the, the thing that allows the range of the key to go like that. Yeah, and by the way, I'm not sure how long, these in here would last, by going bang, 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 bang. I'm sure they've, there might be a finite life to that, but there's not a lot of range of movement in there. I'm sure they've chosen their type of plastic correctly. D56, it just looks like it's ABS. I don't know. Those numbers mean something. F56. Oh, A. Oh, do they go as D? Do they go in a specific location? I don't think so. I think they're all identical moldings. Yep, 28.2, and this one over here has 28.2 as well. Oh, we've got some gunk down in here. Check it out. There you go. That's just like some silicone grease, something like that. Make it smooth as silk. This is interesting. The black keys, though, come in a bigger molding like that. Sweet. And they've got exactly the same on the bottom there. So that contacts this somehow. Ooh, secret sauce time. So this is interesting. This board starts here and goes all the way with LBJ. I think it goes all the way to the end. So that makes sense, because you don't want to have like how long's this thing, like a meter long or something, 900 millimeters. You don't want a board that big going through your pick and place. Whoa, actually is that reflowed? No. Yeah, I think it's reflowed. It's not wave soldered. Anyway, yeah, so they split it in. You don't want one big long board. That's why they've got the two ribbon cables, one here and one over here. But, curiously, they do join. If we have a look down in here, these keys we'll take a look at. But look, this is obviously a single-sided board, and on the top side here, they're using carbon. They just lay down another layer of carbon to actually get in there. Now, this is not going to be a short. These are actually going to have some resistance, so let's measure that. There we go. 47 ohms, 44. It's not exactly controlled. I have done a video on these, what all these carbon tracks are about. Might have to link that in if I remember. But there you go. Yeah, they're not short. Maybe they're they are carbon resistors for a reason, perhaps. But I think the most likely explanation there is that they probably don't have a reason. I think that'd be my best guess, is that they're not actually using them as resistors. They're just using them as jumpers there. The board was obviously cheaper with these, because look, you got all the traces running under there. It's just, what you do on a double-sided layout, because if they wanted resistors, they've already got to put down these little, what are they, diodes, D. There you go. They've already got to put down these diodes and solder those on, reflow, so why not do resistors as well? But the problem with that is that, you have trouble running all your traces that you need. It's just a PCB layout thing under your resistors. You could probably use some MELF, some longer MELF resistors in there perhaps and achieve the same result, but it's pretty narrow in there. Anyway, they've decided to do that instead of a double-sided board. Interesting. And this other black stuff here, it just looks like masking. We're going to have to remove this to see. Oh, it doesn't go all the way with LBJ. Look at that. Wow. Okay. Now for the big reveal. What's under these keys here? Are they capacitive type thing? Because look, they've got two like hole moldings in that, like two contact. They'd be contacts. And so let's lift the skirt up here, because these things look like they're anchored down to the board. I don't really. Am I going to have to pop it out? Oh yeah, we can pop it. There you go. No wuckers. Yeah, she'll be right. Well, I am surprised. They're just your regular membrane keypad contacts on there, done with carbon instead of gold-plated PCB contact. Look at that. They're just your regular carbon contact pads. 2 of them. It's like, what? I expected something a bit more advanced than that, than just contact based. Obviously, like there's 2 of them and they're separate for a reason. Obviously one makes contact before the other does, so that's got to be just a slight angle. So when you press the key down like that, this bottom one connects first, right? It just hits on the bottom there, because they're not angled or anything like that. That's what I said before. I was looking for any sort of like stepped base thing there that we saw in the Yamaha keyboard. You have to check the teardown out of that. It had like 3 layers, if memory serves me correctly. And yeah, so it pushes on that first hole first and then the next hole. So using a combination of those and the timing, I guess, between them is how they can determine the velocity. So that's incredibly simplistic. That's not what I was expecting. I was hoping for some, wing whiz-bang capacitive, like distance sensor or something like that, because I don't think they're doing that. You couldn't do that like over the long cables and everything. It just doesn't work out. They're simply a contact-based system. Well, I'm gobsmacked. But they obviously make it work. But I guess you'd have to have an expert playing this, because I'm not one of them, and to determine how good the velocity feature is in this thing. But at least it has the velocity feature. But yeah, they're just using 2 layers there, and probably almost certainly the timing between them to to realize how far and how fast you're pressing the key. So so much for that. That's all there is to the teardown, really. Sorry. I expected something more advanced, but they're getting away with it. Simply, cheaply. Good on Casio. So this kind of makes sense now why they've done those carbon resistors, in quote marks, up here, because this is a single-sided board, and basically if you wanted like to use your traditional like gold contact membrane pads down here, then, well, they wouldn't have had anything up here for the jumpers. You couldn't put in individual jumper links. That would have cost a fortune. That would have forced them to a double-sided PCB just for layout reasons. The designers decided, no, it's actually cheaper to go for a single-layer board and have the carbon process, and then we can do the carbon pads down here. We can save the cost of the gold flash on the PCB, and we can do away with the individual resistors on there, but the cost of the double-sided board, it was just cheaper to do it like this. So once you decide to go single-sided board to save cost, then you go, well, let's put the carbon on here for the jumpers as well as the contacts. No worries. Well, someone's got to be a rebel. Blue. Somebody in the design department thought, I want blue keys, damn it. It's exactly the same, except they're blue. I think the reason for that, though, is because this has 13 keys and these ones have 12. So it's just a way to differentiate these. They don't mix them up in production. Clever. Because it'd just ruin your day if you picked up a 13-way one and tried to shove it in the 12-way one like you got all the way along. You're pushing in all these little pain-in-the-ass little things down in here, pushing them down. Oh, no, I used the wrong bloody one. Ah, Friday afternoons. Okay, standby current. There you go. Got to wait for caps to charge up. Ah, 6-odd mic, 5-odd mic. It's not too shabby, it's dropping. Not too shabby, huh? This battery's going to last forever on standby. Alright, let's try the operational current. I've got to use 3 hands here. Here we go. 211, 279 once it's powered up. 284, there you go. Oh, nah, turned off. Anyway, a couple hundred milliamps. Anyway, it's always interesting taking a look in low-cost consumer products like this to see how they're designed and engineered to get the price down. I hope you found it interesting. So there you go. I hope you liked that quick look inside this Casio CT-X700 keyboard. And apparently it's like pretty decent for the price. I don't know. Let me know. Comments down below. Stand to be corrected. Anyway, if you liked the video, please give it a big thumbs up. As always, there'll be videos at the end here. I'll put in that Yamaha teardown here and just some other random videos. Check them out. Catch you next time.